One, two, one, two. 1 2 1 2. Check, check. All right, cool. Just so you know, there's some construction going on in my building, so if the noise gets too loud, I'll probably just turn off the mic. But hopping into the next part of Python. So finished Intro to Python in Codecademy yesterday. Did all the coding challenges, and now it's on to intermediate. So we're good, we're good. Okay, cool. Right into it. Introduction to Intermediate Python. And learn Intermediate Python 3 will teach you how to leverage Python's unique features and techniques to build powerful, sophisticated applications. You'll also learn how to expedite your data processing and management, manage your resources, test your code using the unit test testing framework, and more. Here's an overview of the course's modules: functions deep dive, object-oriented programming, iterators and generators, specialized collections, resource management, unit testing. Let's get started. Python gotcha, mutable default arguments. Learn about a common Python gotcha when using mutable default arguments in functions. A Python gotcha. When writing a function with default arguments, it can sometimes be tempting to include an empty list as a default argument to that function. Let's imagine, for instance, we were building an application for a school. We want to have a function that can generate new students and return a dictionary of the student's name, age, and grades. Since most students enter the school without any grades, it's plausible to assume we can store an empty list for the property. Here's what our function might look like. Def create student, name, age, grades equals an empty list, return name, name, age, grades, grades. It looks good so far. We can create 2 new students based off this code, assuming they have no grades yet. Chrisley equals create student, Chrisley 15. Dallas create student, Dallas 16. Realistically, as both Chrisley and Dallas progress in school, there should be a way for us to add new grades. Something like this method: def add grade, student, grades, dot append, grade. To help visualize the grades, we have added a print statement, print student grades. Alright, let's give Chrisley and Dallas some grades. Add grade, Chrisley 90, add grade Dallas 100. Here we expect that the output probably would be 90, 100. That would make sense since we want each student to have an individual grades list. Surprisingly, or maybe not so much, the actual output is 90 and 90, 100. Uh-oh, that doesn't look right. Why does Dallas have the 90 grade that we added to Chrisley when they should only have the 100 we intended to add? This is known as a gotcha, a counterintuitive feature of a programming language that often leads to mistakes in programs. Let's practice catching this gotcha and then dive a bit deeper to understand why this phenomenon occurs. What is the output of the following code? So def update order, new item, current order equals an empty list. Current order dot append, new item. So you add this new item to this current order list and then return the current order. First order burger, order 1 equals update order. Item burger cost $3.50. Second order, just a soda. Order 2, update order, item soda cost $1.50. What's in that second order again? So the idea here is that because we're appending and it returns current order appended, order 2 would have both of these items in it. So print order 2 would have item burger cost $3.50 and item soda cost $1.50. Good job, you got it right. This is a common Python gotcha with mutable default arguments, mutables and functions. To understand this gotcha, we must first establish what Python classifies as mutable. A mutable object refers to various containers in Python that are intended to be changed. A list, for example, has append and remove operations that change the elements of the list. Sets and dictionaries are also 2 other mutable objects in Python, as they can be changed on the fly. So again, a mutable object refers to various containers in Python that are intended to be changed. A list, for example, has append and remove operations that change the elements of the list. Sets and dictionaries are also 2 other mutable objects in Python, as they can be changed on the fly. It might be helpful to note some of the objects in Python that are not mutable. and therefore okay to use as default arguments. Int is not mutable, float is not mutable, and other numbers can't be mutated. Arithmetic operations will return a new number. Tuples are a kind of immutable list, and strings are also immutable, since operations that update a string will all return a completely new string. When using immutable in function arguments, it's important to note the following from the official documentation. Default parameter values are evaluated from left to right when the function definition is executed. This means that the expression is evaluated once when the function is defined and that the same pre-computed value is used for each call. This means that when we call a function, the default values we provide for parameters are only created once and used for each subsequent call of the function. This means our grades equals an empty list from our earlier function was only created once, and anytime we tried to access it, the same list was being modified. We can even see that the memory ID of the grades property for both students is the same, using the built-in ID function. So the IDs printed will vary depending on the computer we are using. Print ID Chrisley grades, print ID Dallas grades outputs the same memory location. The IDs printed will vary depending on the computer we are using, but they will always be the same. While this may seem like a bit of a head scratcher and even a point of contention amongst Python enthusiasts, there is one specific solution that helps us get around this gotcha if we ever do want to use a mutable default argument. Let's take a look at a solution that uses the value none to get around this gotcha. The none workaround. If we want an empty list as a potential default argument value, we can use none as a special value to indicate we did not receive anything. After we check whether an argument was provided, we can instantiate a new list if it wasn't. Here's what the solution looks like for our program from earlier. Def create student, name, age, grades equals none. If grades is none, grades equals an empty list. Return name, name, age, grades, grades. Def add grade, student, grades, dot append grade. To help visualize the grades, we've added a print statement, print student grades. Now if we create our students again and add grades to them, Chrisley equals create student, Chrisley 15, Dallas equals create student, Dallas 16, add grade Chrisley 90, add grade Dallas 100. We will get our expected result, 90, 100. While it may seem more cumbersome to write the if clause, this is one of the most common and flexible ways to avoid running into issues with mutable default arguments. Let's practice by refactoring the last assessment code. Fill in the blank. Fill in the following code to account for the mutable default arguments Python gotcha. The expected output of the solution is item soda cost 150. Def update order, new item current order equals none. If current order is none, current order equals an empty list. Wrap up. To summarize, we learned what a Python gotcha is, what mutable objects are in Python, a common gotcha that occurs when using mutable default arguments, a workaround for mutable default arguments by using none paired with a conditional statement. Keep this gotcha in mind whenever deciding to use a mutable object, as a default argument. While most developers recommend, hit back on accident. Keep this gotcha in mind whenever deciding to use a mutable object as a default argument. While most developers recommend staying away from this approach, there are notable use cases for this syntax that may be worth looking into. Function arguments. A recap. In Python, there are three common types of function arguments. Positional arguments, arguments that are called by their position in the function definition. Keyword arguments, arguments that are called by their name. Default arguments, arguments that are given default values. To recap, here's what each of these argument types looks like. Positional arguments. Def print name, first name, last name, print first name, last name, print name Jiho Baggins. Here, first name will be mapped to Jiho, while last name will be mapped to Baggins due to the position of the arguments when calling a function. Keyword arguments. Def print name, first name, last name, print first name, last name, print name, last name equals Baggins, first name equals Jiho. Here we are using the parameter names first name and last name as keyword arguments in the function call. Notice the order of the arguments does not matter, since they are assigned a specific name. Default arguments: def print name, first name Jiho, last name Baggins, print first name, last name. Now we can just call print name. Here in the function definition, we assign default values to the parameters. This means we can call our function without providing any arguments, because they will have a value to fall back on. While these are the most common argument types in this lesson, we will explore what happens when we want to make our function arguments more flexible by taking a varying number of arguments. Before we jump into learning more about variable argument types, let's review the most common types to get warmed up. Our friend Jiho is trying to get into the restaurant business. They asked us to build a simple table assignment program to help manage which customer is assigned to each table in the restaurant. Jiho wants to store not only the name of the customer for the table, but also if they hold a VIP status earned by visiting the restaurant frequently. Our table information will be stored in a dictionary called tables, already defined in our editor. That is structured in the following format: table number, name, VIP status. Take a second to examine the dictionary and run the code to move on. So we have tables equals 1, Jiho, false, 2, empty list, 3, empty list, and so on. That's printing tables. Jiho needs a way to assign new customers to the existing tables as they come in for their reservations. Define a new function called assign table that will take 3 arguments in this exact order: table number, name, VIP status. Our function assign table should then use the following arguments to assign a new customer to a table in our dictionary tables. Use the following arguments to assign a new customer to a table in our dictionary tables. Use the table number as the key and the list containing name and VIP status as the value. So, function assign table should then use the following arguments to assign a new customer to a table in our dictionary tables. Use the table number as the key and the list. Use the table number as the key and a list containing name as the value. So def assign table. I kind of forget how to do this. Did you create a way to add to tables with the values table number, name? Double check your ordering should match structure provided. So assign table. It's not append for a dictionary. Use square bracket notation. Use the update method. Okay, so tables, table number, equals name, VIP status. Okay, cool. And alternatively, we could have done tables.update, table number, name, VIP status. Looks like our first reservation just came in. Call our function assign table. Using positional arguments for a customer with the name of Yoni to the table 6. So 6, Yoni. Yoni does not have VIP status, and this should have the value false. Optionally, print tables to check that the assignment was successful. Nice. Looks like another customer came in. Call assign table. using keyword arguments in any order to add the new customer with the following details. So let's do name equals Martha, table number equals 3, and VIP status equals true, and then we'll print tables. Awesome. Since most customers are new at the restaurant, we want to use a default value of false for any new table assignment. Modify the function definition of assigned table and give the parameter VIP status a default value of false. So it's false. A new customer just arrived. Add the customer to a table using the following information via positional arguments. So assigned table positional arguments. So for Carla is not a VIP, so we do not need to provide an additional argument since we already have a default value of false in our function definition. Lastly, print the table's dictionary to see the final table assignment. Cool. Variable number of arguments, asterisk args. To start exploring variable argument lengths in Python functions, let's take a look at a familiar function we have been using for a long time, print. This is the print function. Notice how the print function does not care how many arguments we pass to it. It has no expectation that we are going to pass in one argument or even a million. So the question is, how does print accomplish this? Well, in Python, there is an additional operator called the unpacking operator, asterisk. The unpacking operator allows us to give our functions a variable number of arguments by performing what's known as positional argument packing. Let's explore how it works by examining a basic function that utilizes the unpacking operator. Def my function asterisk args print args. If we call this function with random arguments, my function arg1 245 false, our output will show us what is inside of asterisk args. We see in parentheses arg1 comma 245 comma false. Notice two things. In our print call, we simply use the name of args with the unpacking operator omitted. The name of args is completely arbitrary, and this example works just the same. Def my function asterisk random name print random name. Whatever name follows the unpacking operator asterisk will store the arguments passed into the function in the form of a tuple. This allows our functions to accept any number of arguments, just like the print function we examined earlier. In this case, args has 3 values inside, but it can have many more or fewer. Let's practice using the unpacking operator for positional arguments in a function. Jiho wants to expand our restaurant application to also take orders from customers. This is the perfect time to use the unpacking operator, since we never know how many items customers are going to order. To start, we want to build a function that will compile a list of all the items a customer wants to order and then print it out. This will help our kitchen know what to cook. Define a function called print order that will take in a variable number of arguments using a parameter called order items. The function should simply print order items. So def print order looks like our first order came in. Call the function with the following order items. So orange juice, apple juice, scrambled eggs, pancakes. Working with asterisk args. Now that we have seen the basics of working with positional argument unpacking, let's examine how to use it in a more meaningful way. So we wanted to build a function that works similarly to our trusty print statement, but instead prints all of the arguments in uppercase form. Using our knowledge of iteration, combined with the power of the unpacking operator, our solution might look like this. Def shout strings asterisk args, for argument in args, print argument.upper, shout strings working on learning argument unpacking would output that. In our function shout strings, we use a for loop, although we could use any iterator to iterate through each element of the tuple that exists inside of args. Then we use the built-in function .upper to capitalize each argument. The unpacking operator is not limited to being used alone, but rather it can be combined with other positional arguments. Let's examine a function that truncates, cuts off sentences based on a provided length. Def truncate sentences, length, comma, asterisk sentences. For sentence and sentences, print sentence, square brackets, colon, length. So for sentence and sentences, print the sentence up to a length. So we do truncate sentences, 8. What's going on here? It looks like we've been cut off. Would output what's good. Let's break this down. We have two parameters that our function truncate sentences defines. The first is a length parameter that will specify how many characters we want to keep. The second is a parameter called sentences that is paired with the unpacking operator, signifying it will take a variable number of arguments. On each iteration of the function, we are looping through the tuple created by the sentences argument because it is paired with the unpacking operator and performing a slice on the sentence based on the provided length argument. This forces every value in the sentences tuple to be cut down in length. Utilizing iteration and other positional arguments are two common ways we can increase the utility of our functions when using the unpacking operator asterisk. Let's practice using these techniques to see how powerful they are. Jiho is having a lot of success with our restaurant application. Unfortunately, our original design did not account for storing orders for each specific table. Jiho asked us to adjust our application to be able to store the orders that come in for each specific table and also be able to print out the order for the kitchen staff. Take some time to review the adjusted structure of the program we created earlier. Note that tables is now dictionary with the table numbers as keys. So tables equals 1 and then a dictionary with name, Jiho, VIP status false, order, orange juice, apple juice. It also accounts for a new property called order. The assign table function has also been adjusted to account for the changes. Run the code to move on to the next checkpoint. So we see def assign table takes in table number, name, and VIP status, which is set to default. And here we see tables, table number, name. So it goes 1, and then from here looks at the name field, and then assigns name. And we see tables, table number, VIP status, assigns VIP status, tables, table number, order, assigns. Here we see an empty string because assign table isn't taking an order argument. So run the code. To help Jiho implement the ability to store the order in a specific table, let's define a function called assign and print order. The function should have two parameters called table number and order items. The parameter of order items should be grouped with an unpacking operator, so we can capture a variable number of order items per table. For now, our program will error out if we run it. Don't worry, we'll fill in the function in the next step. Our function assign and print order should then assign an order to a table. So inside of our function, access the nested order key for the specific table using the table number argument from tables and set it to the order items parameter. So in addition to assigning the order to our tables dictionary, we also want to print every order item so the kitchen knows what to cook. Inside of assign and print order, use a for loop to iterate through order item. So for item, to iterate through and print Lastly, let's see our function in action. Luckily, we just had a new customer come in for their reservation. Use the assign table function. To add a new customer named Arwa, table 2. Now that Arwa is seated and ready to order, call our assign and print order function for table 2. With the order items of steak, sea bass, and wine bottle, and print tables to see the result. Table number, order items, sign, oh I misspelled it. Nice. Variable number of arguments, asterisk asterisk, keyword args, or KW args. Python doesn't stop at allowing us to accept unlimited positional arguments. It also gives us the power to define functions with unlimited keyword arguments. The syntax is very similar, but uses 2 asterisks instead of 1. We typically call these keyword args as a shorthand for keyword arguments. So you could call it kwargs, but whatever. Let's examine a function that prints out some useful information about kwargs to see it in action. Def arbitrary keyword args, asterisk, so double asterisk keyword args, print type keyword args, print keyword args. See if there's an anything goes keyword arg and print it. Print keyword args.get anything goes, arbitrary keyword args. This arg equals wowzers, anything goes equals 101 with output. So the type of keyword args is a dictionary, so output class dictionary, and then printing keyword args itself is a dictionary with this args, wowzers, anything goes, 101, and then printing out keyword args.get anything goes will print out 101. We can observe 2 things. Double asterisk keyword args takes the form of a dictionary with all the keyword arguments values passed to arbitrary keyword args. Since double asterisk keyword args is a dictionary, we can use standard dictionary functions like .get to retrieve values. Just as we saw with asterisk args, the name of keyword args is completely arbitrary, and this example works exactly the same with the name becoming data, def arbitrary keyword args, double asterisk data. Let's practice using double asterisk keyword args to get a feel of how it works in a function. Jiho is pleased with how we can store orders for our tables. However, the staff now wants to distinguish between food items and drinks. Since food items gets prepared in the kitchen and drinks are prepared at the bar, it's important to distinguish between the two in our application. The tables dictionary has been changed to support the staff's requests. Take some time to examine the changed structure. Run the code to move on to the next checkpoint. So tables is a dictionary, 1, and then, so the key is the table number, and the value is a dictionary with name, VIP status, and the order itself is a dictionary with drinks and food items. Since our program now requires a distinction between food items and drinks, this is a great place to utilize the power of double asterisk keyword args. Define a function called assign food items. That has a 1 parameter order items. Pair this parameter with a double asterisk operator. So name it keyword args to keep it simple. Best parameter with a double asterisk operator handle any keyword arguments. For now, just have the function print order items. What did I do wrong? Assign food items that has 1 parameter. Oh, I see. I misunderstood. Now we want to capture the food items and drinks in order items. Use the .get method to do the following. Capture the values from a keyword argument called food. So now we want to capture the food items and drinks and order items. Use the .get method to do the following. Capture the values from a keyword argument called food and assign it to a variable called food. So we could do order items .get food, and we could assign it to food. Capture the values from a keyword argument called drinks and assign it to a variable called drinks. Refer to the commented example call at the bottom of the script for reference on how we will call this function later on. So later on, assign food items. Food equals pancakes, poached egg, drinks equals water. Lastly, inside of our function, use print to output the food variable and another print to output the drinks variable. Uncomment the example call provided to test our function. Nice. Working with double asterisk keyword args. Working with double asterisk keyword args looks very similar to its asterisk args counterpart. Since double asterisk generates a standard dictionary, we can use iteration just like we did earlier by taking advantage of the .values method. Here's an example. Def print data, double asterisk data for arg and data.values, print arg. Print data A equals arg1, B equals true, C equals 100. So again, since double asterisk generates a standard dictionary, we can use iteration just like we did earlier by taking advantage of the .values method. Here's an example. So if we do def print data, double asterisk data for arg and data.values. So it's just saying for everything in data, print it. Print data A equals arg1, B equals true. So it's just print all these. We can also combine our use of double asterisk with regular positional arguments. However, Python requires that all positional arguments come first in our function definition. Let's examine how this works. Def print data, positional arg, comma, double asterisk data. We can also combine our use of double asterisk with regular positional arguments. Okay, all positional arg come first. Okay, so print positional arg for arg and data.values, print arg, print data position 1, A equals arg1, B equals true, C equals 100. If we were to switch the position of positional arg to come after double asterisk data, we would be met with a syntax error. Let's expand our restaurant application from the previous exercises to apply the flexibility of using double asterisk keyword args in our functions. In the last exercise, we saw how using double asterisk allowed us to capture different food items that a table will order. In the next few checkpoints, we will finish implementing the functionality of our assign food items function. Take some time to get reacquainted with the program. Note the changes in the assign food items function. Run the code to move on. So tables is this, def assign table, table number, name, VIP status. We're assigning these arguments to these places in our dictionary. Assign table to Douglas, true. Print tables with Douglas. Define assign food items. Takes the keyword arguments, order items. Food equals order items dot get food. Drinks equals order items dot get drinks. Take some time to get reacquainted. Note the changes in assign food items. There's these commented out tables. Table number, order, food items is equal to food. Tables, table number, order, and this is happening in the function, but it doesn't have the table number explicitly, does it? It's confusing to me. Unfortunately, when we originally implemented assign food items, we did not assign the values we capture into our table's dictionary. Adjust the function definition of assign food items. Add a positional parameter called table number followed by the asterisk order items parameter we already defined. Uncomment the 2 lines inside the function. Great, now that we have the base functionality set up, let's give it a test run. Luckily, a new customer named Douglas just came in and is ready to place an order. Under print tables after update, call the assign food items function. With the following arguments: a positional argument table number, positional, a keyword argument food with the value sea bass, gnocchi, and pizza, a keyword argument drinks, oh yeah, margarita water, print tables to see the change. Nice. All together now. So far we have seen how both asterisk args and double asterisk keyword args can be combined with standard arguments. This is useful, but in some cases we may want to use all 3 types together. Thankfully, Python allows us to do so as long as we follow the correct order in our function definition. The order is as follows: standard positional arguments, asterisk args, standard keyword arguments, double asterisk keyword args. As an example, this is what our function definition might look like if we wanted a function that printed animals utilizing all 3 types: def, print animals, animal 1, animal 2, asterisk args, animal 4, double asterisk keyword args. So if we do print animal 1 and animal 2, we do print args, print animal 4, and then print keyword args. We could call our function like so: print animals, snake will go to animal 1, fish will go to animal 2, guinea pig and owl will go to args, animal 4 equals cat will go to animal 4, and animal 5 dog will go to keyword args. And our result would be, so snake, fish get printed out as so, just the strings get printed out with the space in between. And guinea pig, owl, since they're part of args, they become a tuple. So a tuple of guinea pig, comma owl. Cat is printed out on its own. Interestingly, I wonder why it's colored like that. And then for keyword args, it's a dictionary. Animal 5, dog. That is a whole lot of arguments. Let's break it down. The first 2 arguments that our function accepts will take the form of standard positional arguments. When we call the function, the first 2 values provided will map to animal 1 and animal 2. Thus, the first line of output is snake, fish. The non-keyword arguments that follow after snake and fish in our function call are all maps to the args tuple. Thus, our result is tuple guinea pig, comma owl. Then we transition to regular keyword arguments. Since we called animal 4 as a keyword, our result for the print statement is cat. Lastly, we have one more keyword argument that is mapped to double asterisk keyword args. Thus, our last line of output is a dictionary animal 5, dog. Let's practice putting it all together in our restaurant application for Jiho. For an upcoming holiday, Jiho plans on making a pre-fee, I don't know what that menu for the restaurant. Customers at the restaurant will be able to choose the following: 1 appetizer, 2 entrees, 1 side dish, 2 scoops of different ice cream flavors for dessert. To accomplish all these choices, we're going to utilize the different types of arguments that we have learned so far. Now that we've set up our goals, hit run to move on to the next step. Let's start by defining a function called single prefix order, which will define 4 parameters to accept the full order. So parameter named appetizer, entrees with an asterisk operator. So we could take any number of entrees. Parameter named sides, which will need to be a keyword argument, and then a parameter named dessert scoops. I can already see where this is going. Dessert scoops paired with a double asterisk operator. Our function should simply have 4 print statements that print each individual parameter. Now entries. We got our first prix fixe order in. The customer wants to follow me. Baby Beats as an appetizer, salmon and scallops as entrees, mashed potatoes as a side, a scoop of vanilla ice cream, and a scoop of cookies and cream for dessert. Utilize our function single prix fixe order. So to print out all of the customer's orders. So I guess I could set anything for the keyword args. So Baby Beats, salmon scallops, mashed potatoes, scoop 1 vanilla, scoop 2 cookies and cream. Function call, unpacking and beyond. Hopefully by now, we have started to see the power of using the asterisk and double asterisk operators in our function definitions. However, Python doesn't stop there. Not only can we use the operators when defining parameters, but we can also use them in function calls. Let's imagine we want to sum a few numbers together. Def sum num1, num2, num3, print num1 plus num2 plus num3. Right now, our function forces us to pass in an individual argument for num1, num2, and num3. This isn't a big issue if we have separate variables or know our numbers in advance. However, what if we wanted to use a list like 3, 6, 9 instead? Well, that is where the unpacking operator comes to the rescue. Let's observe. My num list equals 3, 6, 9. Def sum num1, num2, num3, print num1 plus num2 plus num3, sum asterisk my num list would output 18. So what's happening here? Well, by using the unpacking operator asterisk, we are spreading the contents of our list, my num list, into the individual arguments in our function definition. We are immediately saved the hassle of writing loops and are given the flexibility to use any iterable with 3 elements. This way of using the asterisk in a function call also applies to our keyword operator, double asterisk. As long as the keywords match the function parameter names, we can accomplish the same goal. Numbers equals a dictionary num1, 3, num2, 6, num3, 9. Def sum num1, num2, num3, print num1 plus num2 plus num3, sum double asterisk numbers would output 18. Slow down and really let it sink in. So this way of using the asterisk in a function call also applies to our keyword operator double asterisk. As long as the keywords match the function parameter names, we can accomplish the same goal. So if numbers is a dictionary, num1 is 3, num2 is 6, num3 is 9. Define sum num1, num2, num3, print num1 plus num2 plus num3. We can do sum double asterisk numbers to output 18. Again, this is unpacking. So it's an unpacking operator. We're spreading the contents into the individual arguments in our function definition. We can even use the operators inside of built-in functions. For example, instead of manually providing the range built-in function with a start and stop value, we can unpack a list directly into it. Let's take a look. So start stop is a list of 3 and 6. Range values equals range asterisk start and stop. To unpack it, print list range values would output 3, 4, 5. The possibilities of using the asterisk and double asterisk operators are endless. Observe some more clever use cases. Unpacking parts of an iterable. A asterisk B C equals 3, 6, 9, 12, 15. Print B would output 6, 9, 12. Unpacking parts of an iterable. So that's interesting. So if we have this list of 5 numbers, and we can assign it to 3 variables by using an asterisk in one of the variables to unpack it, or at least in the middle variable. I'm curious how it would react if we moved the asterisk to A or C. Would if we moved it to A, would it be 3, 6, 9? And if we moved it to C, would it be 9, 12, 15? Merging iterables. My tuple equals 3, 6, 9. Merge tuple equals 0. Asterisk my tuple 12. Print merged tuple would output 0, 3, 6, 9, 12. Combining, unpacking, and packing. Num collection equals 3, 6, 9. Def power 2 asterisk nums. For num and nums, print num to the power of 2. Power 2 asterisk num collection would output 9, 36, 81. Let's see how we can apply some of these use cases to make Jiho's restaurant application better. Jiho thinks our restaurant application is missing one really important feature. Jiho would like for the application to be able to calculate the total bill of a table, including tip, and split it based on the number of people at the table. Thankfully, we had an existing function called calculate price per person from our last restaurant project that we can reuse. Take some time to examine the function and its inner workings. Run the code to move on to the next checkpoint. Don't worry, we shouldn't see any output just yet. So we have this function def calculate price per person. It takes in a total, a tip, and a split. Total tip equals total times tip divided by 100. Split price equals total plus total tip divided by split. Print split price. Okay, let's run it. Let me X this. Looks like we are ready to give our function a test run. Luckily, table 7 at Jiho's restaurant is ready to pay. Define a list called table 7 total. So table 7 total is a list that has the following values in order: 5, 3, 4.50 representing the total bill cost, 20.0 representing the tip percentage, 5 representing the number of people to split the bill for. Using the unpacking operator, call calculate price per person with the list table 7 total. So this will unpack this to be the total, unpack this to be the tip, and unpack this to be the split. Nice. Review. We covered a lot of ground in this lesson. We learned all about how functions can accept different arguments and different styles in which we can pass those arguments in. We learned how to pack positional arguments in a function with asterisk args, how to work with asterisk args using iteration and other positional arguments, how to pack keyword arguments in a function with double asterisk keyword args, how to work with double asterisk keyword args using iteration and other keyword arguments, how to combine all different types of arguments to gain the most flexibility in our function declarations, how to use an unpacking operator, asterisk or double asterisk, to unpack arguments in a function call, how to use an unpacking operator, asterisk or double asterisk, on iterables, we should now be able to read many different styles of function writing in Python and come up with ways to call those functions with style and clarity. Take some time to examine the application we built for Jiho. The program has been adjusted to account for the payment calculation from the previous step. Play around and have fun with our new knowledge of function arguments. Here's some additional functionality that Jiho might like: the ability to remove a table's guests when they leave the restaurant, the adjustment to the calculate price per person function to access a table's total and return the result, the ability to add and remove order items for both food and drinks if there is ever a mistake, the ability to queue reservations for later times for specific tables. So let's try to add it. So take some time to examine the application we built for Jiho. Program has been adjusted to account for the payment calculation from the previous step. Play around and have fun with our new knowledge of function arguments. Here's some additional functionality. So let's first add the ability to remove a table's guests when they leave the restaurant. So define a function, remove guests, takes in table number, so I guess we could do if tables table tables table number order total is not none. Then tables table number equals an empty dictionary. So we could do print tables. So we see here we have all the tables are empty except for table 1. So if I do remove guess and I pass in table 1, and then we do print tables, see here tables are empty now. An adjustment to the calculate price per person function to access the table's total and return the result. Calculate price per person. We need to adjust it to access the table's total and return the result. I'm confused. What do you mean access the table's total and return the result? So because it's receiving the total, that's just a weird request. Whatever. The ability to add or remove order items for both food and drinks if there's ever a mistake. So if there's a mistake, we should be able to go into tables and add an order item or remove an order item. I don't know. I'm gonna keep moving. Like I could do it, it just doesn't seem the best use of my time. Which of the following would not be a valid function declaration? Def func. This is not valid because this needs to be at the end. valid, valid, and not valid. Which of the following would not be a valid declaration? I didn't think either of these would be valid. But I guess if param1 is a keyword argument, it's valid. What's wrong with this function definition? Def adds signature message, list of paragraphs equals an empty list, list of paragraphs dot append, signature message, return list of paragraphs. List of paragraphs is returned, but we're mutating an existing object, so we should return none. List of paragraphs is given a default argument of an empty list, which I think I hit the back button on accident. That's interesting, it makes it random. What would the result of the following code be? Def unite args, new string, it's an empty string for arg and args, new string plus equals arg, print new string, unite args, I'm here for this. It's a type error because the function is called with the wrong number of arguments. No, I thought it's a type error. I thought strings were immutable. So for arg and args, new string plus equals arg, I'm, so I guess it's I'm here for this. I didn't think you could do that. What's wrong with this function definition? Def, okay, so just need to errors if it's called multiple times, yeah. How would you pass my list into the following function? So def item summer asterisk args, current sum equals 0. For arg in args, current sum plus equals arg, return current sum. So you're going to want to add an asterisk here so that it unpacks this list. Item summer is my list. Give our play video function a speed parameter that has a default argument of 1. So def play video URL frame rate speed equals 1. Which of the following would not be a valid function declaration? Def func, oh yeah, it was this one, right? What is an acceptable way to call the function? Def find string, double asterisk keyword args. What is an acceptable way to call the function? So for keyword arg in keyword args dot items, so we're looking for pairs. So we're looking for the key and the value in the dictionary of our keyword arguments dot items. Print arg dot find keyword. So if we pass, what is an acceptable way to call the function? So we can pass it keyword args would be Waldo, here's Waldo, or we could pass it Waldo equals long sentence with Waldo in it, or we could just pass it Waldo. So it needs to be a keyword. So it's either 1 or 2, but I believe it's 2. And it's saying for keyword arg, so Waldo is the keyword, long sentence with Waldo in it is, but see, because we're using the dot items, we're assuming that we're receiving a dictionary already. So it's saying for keyword args, and keyword args is items, print arg. So here's Waldo dot find. I think it's this. Damn it. Keyword args allows for any keyword argument to be passed. Sorry. Oh yeah, because it was already a dictionary, so we didn't need to, whatever. I'm not doing the project, going on to namespaces and scope. 1 2 1 2, just checking. Introduction to names and namespaces. In Python, a name, sometimes also called a symbolic name, is an identifier for an object. In the programs we've written so far, we've been using the concept of naming all along. Let's take a look at an example. Color equals cyan. Here we assign color That's the name of the string cyan. Python uses the system of names so that it can differentiate between each distinct object, such as a string or a function that we define. In most programs, Python has to keep track of the hundreds and sometimes even thousands of names. So, how exactly does Python store all of this information? Well, it creates what is called a namespace. A namespace is a collection of names and objects that they reference. Python will host a dictionary where the keys are the names that have been defined and the mapped values are the objects that they reference. In the example above, the namespace Python creates would look something like this: color, cyan. So in this case, if we tried to print the variable color, Python would search the namespace defined above for a key named color and provide the value to be run in our program. Thus, we would see the output of cyan. In the next exercises, we will explore 4 distinct types of namespaces that Python generates: built-in, global, local, and closing. We'll learn all about the different types and how they are generated and managed. For now, let's examine a visual representation of how namespaces get generated. Take some time to look over the provided visualization of namespaces. Notice that different scripts will generate different namespaces. So here we see Python script A, first name equals Marcus, last name equals Poe, def print name. So we see first name, colon Marcus, last name, colon Poe, print name, colon function print name at memory location. Python script B, num equals 5, def countdown. So we see num is 5, countdown, function countdown at its memory location. So interesting. Built-in namespace. So built-in namespace, global namespace, local and closing namespace. One of the 4 main types of namespaces that exist in Python is the built-in namespace. Ever wonder why functions like print and string are available to us in all our programs? Well, Python knows these function names because they exist in the highest level of namespaces and thus can be called in any program we write. Whenever we run a Python application, we are provided a built-in namespace that is created when the interpreter is started and has a lifetime until the interpreter terminates, usually when our program is finished running. Since Python provides the namespace, these objects are accessible without the need to import a separate module. Let's take a look together at the standard built-in namespace. In order to see it, we can use the following statement: print dir underscore built-ins underscore, so dunder, right? This allows us to access the built-ins module that Python provides for us. Our output would give us arithmetic error, assertion error, a bunch of errors, and then this build class, debug, a bunch of dunders, and then some functions: apps, all, bool, bytes, float, exit, hash, help, and so on. Wow, that's a bit overwhelming. Let's note a few interesting facts about the object's hosted built-in namespace. It contains many of the built-in functions we are able to use in our Python programs, such as string, zip, slice, sorted, and many more. It also hosts many of the exceptions that we may encounter in our programs, such as arithmetic error, index error, key error, and many more. There are even constants like true and false. In total, there are 152 names that include exceptions, functions, types, special attributes, and other Python built-in objects. Let's re-examine everything that exists in the built-in namespace. Use the print function combined with the directory function, so print directory, to print out built-ins. Take some time to examine the contents of the namespace further and even read about the module in the Python documentation. It's a lot of stuff. Global namespace. The global namespace exists one level below the built-in namespace. Generally, it includes all non-nested names in the module file we are choosing to run the Python interpreter on. The global namespace is created when we run our main program and has a lifetime until the interpreter terminates, usually when our program is finished running. For example, take this program, imaginary file main.py, import random, First name equals Jaya, last name equals Bodegard. Def print variables, random number equals random.randint 09. Print first name, print last name, print random number. Our script consists of a few different variables, a function, and an imported module. Right off the bat, it might not be clear what exists in the global namespace. Thankfully, in order to see what objects exist in the global namespace, Python provides the global's built-in function. Funnily enough, the global's function actually comes from the built-in namespace and is thus called a built-in function, and we can access it anywhere in our program or any program. Let's see what it will return if we print the output inside of the program above. So code from above omitted for brevity. Print globals with output name, main, doc, none, package, none, and so on, a bunch of stuff. So its name is main. Its loader is that. Anything interesting? The file is called main.py. Random is the module random from Python's random. First name is Jaya, last name is Bodegard. Print variables is a function at that memory location. Again, we have a lot of nonsense looking text. Don't worry, there are only two things we should focus on. The global namespace contains all of the non-nested objects of our program. This includes the variables first name and last name, as well as the function print variables. However, the random number variable is not included in the namespace because it is nested inside our function. Don't worry, we will learn about the namespace that random number exists inside in the next exercise. Anytime we use the import statement to bring in a new module into our program, instead of adding every name from that module, such as all the names in the random module, to our current global namespace, Python will create a new namespace for it. This means there might be potentially multiple global namespaces in a single program. This will be masked away from us in the format seen with the random module random from there. Don't fret over the rest of the namespace we didn't touch on. It is a lot of behind the scenes built-in Python objects that are usually present in all scripts. For now, we will focus on the parts we can manipulate. Let's practice using the globals function to check out the global namespace in a program. Note, since we will be printing a lot of namespaces, the current editor has markers for where to write each checkpoint. Let's start by examining the global namespace when the script is empty. Call globals inside of a print function to observe the current global namespace. So, print globals. Globals namespace with empty script is all of that. So name is main, doc none, package none, loader, frozen import lib external.source file loader object at that memory location, spec is none, annotations is an empty dictionary, built-ins is a module built-ins, built-in, file is script.py, cached is none. Now let's add some Python code to see how the namespace changes. Add a variable called the global variable with the value of global. Let's add some more code to populate the namespace. Add a function called print global. That does the following. Defines a variable inside called global variable. With the value of nested global. Defines a variable inside called nested variable with a value of nested value. Let's examine how the global namespace has changed. Print the global function once more. Oh, sorry. Yeah, that is hard to see. Name, main, doc none, So it changes. Let's start from the bottom. Print global is a function. Print global at that namespace. At that memory location, and global variable is global. Here are some important takeaways to note from the comparison. As we saw previously, the global namespace only contains items that are non-nested. In this case, our global namespace does not contain the identical nested name of global variable. Depending on where we call globals, we will have a different namespace generated. This means globals will show the namespace at the time it was executed. Since we call globals a second time after defining a few items, such as variables and functions, those items now show up in the global namespace. Play around with the code, run it one more time to move on to the next exercise. So what would happen if we ran it in there? We got rid of these. And we called the function. Global. So still we're not seeing nested variables. Interesting. Okay, give me 2 seconds. I gotta grab a hoodie. Local namespace. Now that we have examined the built-in and global namespaces, let's dive into the deepest level of namespaces, the local namespace. To do so, let's start by examining this program. Global variable equals global, def add num1, num2, nested value equals inside function, print num1 plus num2, add 5, 10. Here we have defined two values, a global variable and an add function. In Python, whenever the interpreter executes a function, it will generate a local namespace for that specific function. This namespace only exists inside of the function and remains in existence until the function terminates. Similar to how we can see the global namespace using a built-in function called globals, Python provides a function called locals to see any generated local namespace. Let's refactor our program just slightly and see what exists inside of a local namespace. Global variable equals global, def add num1, num2, nested value equals inside function, print num1 plus num2, print locals, add 5, 10, with output 15, num1 colon 5, num2 colon 10, nested value colon inside function. So again, that didn't really sink in. So we have this global variable equals global, def add num1, num2, nested value equals inside function, print num1, num2. If we run add with 5 and 10 as arguments, define two values, a global variable and an add function. In Python, whenever the interpreter executes a function, it will generate a local namespace for that specific function. This namespace only exists inside of the function and remains in existence until the function terminates. Similar to how we can see the global namespace using a built-in function called globals, Python provides a function called locals to see any generated local namespace. Let's refactor our program just slightly and see what exists inside of a local namespace. So here we've just added the print locals with output 15 for these and the local variables inside this function, which are num1 is 5, num2 is 10, nested value is inside function. Notice the following. We call locals inside the add function to get the local namespace generated when the function is executed. If we called locals outside of a function in our program, it behaves the same as globals. The value printed from calling locals represents the namespace that only exists inside of the function. Notice even the function parameters num1 and num2 exist alongside the variable name nested value. The namespace does not include global variable since it exists outside of the function in the global namespace. Let's now practice examining the local namespace. Note, since we will be printing a lot of namespaces, the current editor has markers for where to write each checkpoint. First, let's look at the differences between the global and local namespaces for a file with one variable defined. In the code editor, write two print statements that print locals and print globals. So global variable is that, print local and global namespaces with empty script, write checkpoint 1 here, print globals and print locals. Examine the output of both. They're the same. Now that we have seen what a local namespace looks like without any other code, let's add some functions so we can check out local namespaces inside of a function. Create a function called divide. That's two parameters, num1 and num2. The function should create a variable called result. Hold on, let me move this over here so I can see the keyboard. The function should create a variable called result. That is the result of dividing num1 by num2. The function should then also print locals. Let's add some more names. Create a function called multiply. Multiply. It has two parameters, num1 and num2. The function should create a variable called product. That is the result of multiplying num1 by num2. This function should also print locals. To see our local namespace inside divide, we need to execute it. Call divide with the values of 3 and 4. Examine the local namespace it generates. We see result is 0.75, num2 is 4, num1 is 3. To see our local namespace inside multiply, we need to execute it. Call multiply with the values of 4 and 50. Examine the local namespace it generates. Notice any similarities? Product, num2, 50, num1, 4. Let's examine how the local namespace outside of the functions has changed. Print locals once more. So it seems multiply and divide. So it's changed by, now we have these functions in the local namespace. Enclosing namespace. There's just one more namespace we need to be aware of in our Python programs. This particular namespace is a special type of local namespace called the enclosing namespace. Enclosing namespaces are created specifically when we work with nested functions. Just like with the local namespace, will only exist until the function is done executing. Let's take a look at an example. Global variable equals global, def outer function, outer value equals outer, def inner function, inner value equals inner, def inner nested function, sorry, well, let me focus on this. If we call inner function, and we call outer function, in this program, the following occurs. We define a function called outer function and nest another function inside it called inner function. To generate a namespace, functions must be executed, so we are calling both of them. Here, the outer function serves the role of an enclosing function, while inner function is an enclosed function. By creating this structure, we generate an enclosing namespace, a namespace created by an enclosing function and any number of enclosed functions inside it. While Python doesn't give us any particular function like, oops, didn't mean to do that. While Python doesn't give us any particular function like enclosing to visualize the namespace, we can use locals to see when enclosed namespaces are generated. Let's take a look by modifying our script. So here we've added a call to inner function and a print locals with output outer value, outer, inner function, function outer function dot locals dot inner function add this memory location. Notice the inner function outer function dot locals inner function shows that our local namespace inside of outer functions encloses the local namespace of inner function. Let's practice accessing the enclosing namespace in a similar example. So just to have a better understanding. So from within our outer functions function, we've defined this inner function. And then back within outer function, we've called inner function. We've printed the locals of outer function, which will have this outer value outer and this inner function, which is a function within outer function, and the inner function is at this memory location. Okay, examine the nested functions in the code editor. Let's try to examine the enclosing namespace. At the line that says add locals, this is a discrepancy, but add locals below, print the locals function. Spot anything significant. So this is in our inner function. So inner nested function is defined here is a function outer function dot locals dot inner function dot locals dot inner nested function is at this memory location, and inner value from here is inner. Review. Great job. You've learned some important concepts in Python regarding namespaces. In this lesson, we've covered names as identifiers for objects in Python, what namespaces are, the built-in namespace and how to access it using dunder built-ins, dunder, the global namespace and how to access it using globals, the local namespace and how to access it using locals, the enclosing namespace, a special type of local namespace that occurs when working with nested functions. Knowing these concepts allows for stronger mastery of Python, since names are the basis of how our programs store and retrieve information. Keep up the great work. Take some time to review the namespace structure that was covered in this lesson. So built-in namespace, global namespace, a local or enclosing namespace. Fill in the code so that the function greeting_func prints the function's local namespace directory after printing the greeting message hello alabaster. So def greeting_func with an argument with a parameter name, message equals hello, message with name equals message plus a space plus name per message name. So fill in the code so that the function prints the function's local namespace directory after printing the greeting. So print locals. In Python, a name is an identifier for objects such as variables and functions. It's true. If we ran the code block below, would the output of the first print statement, print globals, be the same or different from the output from the last print statement, print locals? So we run print globals, but because this function wasn't defined before print globals, it won't have this. If we print locals, it'll be similar, but now it'll have this function at the end, so they'll be different. Consider the code block below and fill in the blanks. Relative to the nested function, nested add things, the name x is in the, so x is in the global namespace, double value, relative to the nested function, double value is in the local namespace, and quad value is in the enclosing namespace. So global, local, enclosing. I see names defined in the function are in the local namespace of that function. Names defined in an enclosing function are in the enclosing namespace of the nested function. Names defined outside of functions will be, okay, I understand. Which of the following statements would correctly print the built-in namespace? Dir, dunder built-ins, print, correctly print the built-in namespace, print, dir, dunder built-ins, print, dir, dunder built-ins. Try to trick me there. Which of the following would be the closest representation of the dictionary returned from the print globals on the last line of the script? Again, closest representation of the dictionary returned from the print globals on the last line of the script. So we have x equals 10, y equals 20, def addition. So print addition. So the globals are x, y, and addition at its location. X10, Y20, X10, Y20 right here. Fill in the blank. A namespace in Python is a blank that contains names and the objects that the names refer to. It's a dictionary. Nice-ish. What's next? Introduction to scope. Built-in scope, global scope, enclosing scope, local scope. Recall in Python, namespaces are the backbone of how our programs are stored and retrieved. However, knowing about namespace mechanism isn't enough to explain the following behavior. Def print color, color equals red, print color. If we run this code, our output will give us name error, name color is not defined. Well, that's puzzling. We can see that there clearly exists a name called color. We know anytime we define a variable, it gets added to a namespace. If we can't seem to access it, what gives? Well, this is where a concept called scope comes into play. Scope defines which namespaces our program will look into to check names, and in what order. While multiple namespaces usually exist at once, this does not mean we can access all of them in different parts of our program. Exploring the concept of scope will allow us to start recognizing when and where certain objects may or may not be accessed. Similar to namespaces, there are 4 different levels of scope. These levels are 1. Built-in scope. We will skip talking about this scope. 2. Global scope. 3. Enclosing scope. 4. Local scope. Those 4 scope names should look very similar, since those are also the 4 namespaces we talked about. Each of these scopes is a different level of access to the namespaces our programs generate. In the next few exercises, we will examine each of these scopes. Note, as we explore the ideas around scope, there may be some confusion between what distinguishes the concept of scope and namespaces. While both concepts are interlinked and work together, namespaces are simply the mechanism for storing name-object pairs, while scope will serve as a rule system on which point in our code we can retrieve those names. Take some time to review the structure of the scope in Python. Note any similarities you notice compared to the namespace structure that was covered in the previous lesson. Built-in, global, enclosing, local. Local scope. Let's return to our puzzling example from the previous exercise. Def favorite color, color equals red, print color. Whenever we decide to call a function, a new local scope will be generated. Each subsequent function call will generate a new local scope. Since the local scope is the deepest level of the 4 scopes, names in a local scope cannot be accessed or modified by any code called in outer scopes. As a rule of thumb, any names created in a local namespace are usually also locally scoped. In this case, the name of color is scoped locally to the function favorite color. Since the statement print color is called outside of the function, it has no access to the local scope, and thus the local namespace inside of favorite color, and returns an error. However, if we were to refactor our code, def favorite color, color equals red, print color, favorite color, then we wouldn't have trouble accessing the name of color, since now the print function is scoped locally, and our output will return red. Let's take some time to practice the basics of local scope. Our close friend Jiho wants to start a painting business. In order to help, we have created a small painting application that will print out the required colors for a specific painting. Take some time to examine the code provided and run it to see an error come up. Why are we getting an error? So def painting accepts paint colors and picture. Painting statement equals to paint the plus picture. We need the following colors. For color and paint colors, print the color. Print painting statement. We'll get an error because it's not going to be defined, so it's a name error because this is outside of the scope. This print statement is outside the scope of painting statement variable. Painting saffron, white, green, Indian flag. So it's calling this with the paint colors list, and the Indian flag is a picture. Let's fix the scoping error by moving the print statement right above the for loop. Above the for loop defined in the painting function. This will put the function call in the correct local scope to be able to access painting statement. Nice. Enclosing non-local scope. Similar to how nested functions form a unique namespace within their enclosing functions, the enclosing namespace, there also exists special rules that apply for accessing nested values. These rules make up the enclosing scope, also known as non-local scope. Let's take a look at a nested function to see the scope in action. Def outer function enclosing value equals enclosing value, def nested function, nested value equals nested value, print enclosing value, nested function, outer function. Our output would be enclosing value. Enclosing scope allows any value defined in an enclosing function to be accessed in nested functions below it. We can observe this scope since the nested function can access a variable defined one level above in the enclosing function, outer function. We can also observe this scoping rule further if we nested a function one level deeper. Def outer function, enclosing value equals enclosing value, def nested function, nested value equals nested value, def second nested, print enclosing value, print nested value, second nested, nested function, outer function, would output enclosing value, nested value. There are two caveats to be aware of with enclosing scope. The flow of scope access only flows upwards. This means that the deepest level has access to every enclosing namespace above it, but not the other way around. Makes sense? Well, I'll read it. For example, if we tried to access nested value from one level above where it was defined, can't print nested value because it's a name error, it's not defined. Immutable objects, such as strings or numbers, can be accessed in nested functions, but cannot be modified. Let's try to change enclosing value to see this restriction in action. So if we do outer function enclosing value, def nested function, enclosing value plus equals changed, nested function print enclosing value, would output unbound local error, local variable enclosing value referenced before assignment. So this was referenced before assignment. Now let's practice accessing values in the enclosing scope. A new addition to our painting application that we are building for Geho will be a function that calculates the amount of paint needed to cover a surface. Typically, a gallon of paint can cover about 400 square feet. Using that knowledge, we can use the width and height of a surface to determine how much paint is needed. Throughout these exercises, we will use nested functions to add more utility to the calc paint amount function. Remember, this now makes calc paint amount an enclosing function. Run the code to move to the next exercise. So calc paint amount takes a width and a height. Square feet equals width times height. Printing number of paint gallons needed. Printing string, calc paint amount, and passing 30 and 20, which multiplies them. $30, $20. Oh, it's not returning anything though. First, inside of calc paint amount, define a nested function called calc gallons. So that has no parameters. Then inside of calc gallons, use enclosing scope to access the variable square feet from the calc gallons function. Return the result of square feet divided by 400. Return square feet divided by 400. Finally, in the calc paint amount function, call the calc gallons function. So call and return the result. Run the code. We could just run the code and take a look at the result. Nice. Modifying scope behavior, non-local statement. We just witnessed that we can access names from the enclosing scope with nested functions, but we cannot modify them. Python does, however, provide a way for us to modify names in the enclosing scope by using the non-local statement. Given the following enclosing and nested function, there is a variable defined in the enclosing scope which is not modifiable from within the nested function. So we see def enclosing function, var equals value, def nested function, var equals new value, nested function, print var, enclosing function, the output would be value. So, makes sense? As the value of var was not modified by the nested function, after using the non-local statement, the variable is now modifiable from the local scope. So, def enclosing function, var equals value, def nested function, non-local var equals new value, nested function. So we run this, and then we print var. So this is changing the value of var. We print it, and the output would now be new value. Let's practice modifying variables in a nested context in our painting application for GHO. The users of our applications have requested that we add a way of calculating the amount of paint needed for multiple rooms. To accomplish this, the function calcPaintAmount now accepts a single parameter, wall measurements, which should be a list of tuples containing the width and height of each wall. The nested function calcSquareFeet has been added to iterate through a list and add up the square footage. This function is then called within calcPaintAmount. Run the code and notice the unbound local error regarding the variable square feet. Move to the next task to fix this. So walls is a list of tuples. We define this function calcPaintAmount, which takes in wall measurements. Square feet is 0. We define this function calcSquareFeet, which just has this for loop, which for width and height and wall measurements. Square feet plus equals width times height. And we have another function calcGallons returns square feet divided by 400, which it won't have access to the square feet, which is the issue. calcSquareFeet. Oh, or it won't have access to this square feet, but it will have access to this square feet. calcSquareFeet. So we're running this. So when we pass it walls, so it gets past this list of tuples, and we try to run calcSquareFeet. So for width and height in here, square feet plus, so we're trying to add 20 times 9 to square feet for each of these, and then we're trying to return calcGallons. So define calcGallons, which isn't taking anything, and saying return square feet, which would be that divided by 40. So the user of our application requested that we add a way of calculating the amount of paint needed for multiple rooms. To accomplish this, the function calcPaintAmount now accepts a single parameter, wall measurements, which should be a list of tuples containing the width and height of each wall. The nested function calcSquareFeet has been added to iterate through the list and add up the square footage. This function is then called within calcPaintAmount. Run the code and notice the unbound local error. Local variable square feet is referenced before assignment. Move to the next task to fix this. So just to be clear, in up here, when we tried to print var, it would give us this value. So when we're returning square feet in this calc, I guess I'm just a little confused why it's not returning this square feet, like just 0. Run square feet, and we try to set the value, try to reset this value, but it's only local to this. So when we run nested function, then we print var, it wasn't modified. So it's saying we can't modify this. Maybe I'll understand it better when I try to do this. Since we need to modify square feet in an enclosing scope, make sure to mark the variable as non-local in the appropriate place. So I'm pretty sure it would be non-local square feet here. Let me run it and it works. Why didn't it work before? Because we're trying to modify it within here, which we can't do. But why do we get an error? Okay. So if we do all this and we don't do square feet, we just do calcGallons, it's getting 0 divided by 400 and returning that, which is 0. But the second that we try to use calcSquareFeet and modify this, we're gonna get an error because we can't modify it. Got you. Makes sense. Just to see that error again. Unbound local error. Local variable script for reference before assignment. Got you. Global scope. At the highest level of access, we have the global scope. Names defined in the global namespace will automatically be globally scoped and can be accessed anywhere in our program. For example, global scope variable gravity equals 9.8, def get force mass, return mass times gravity, print get force 60. So again, at the highest level of access, we have the global scope. Names defined in the global namespace will automatically be globally scoped and can be accessed anywhere in our program. Would output that. However, similar to local scope, values can only be accessed but not modified. For example, if we try to manipulate the value of gravity, so gravity equals 9.8, def get force mass gravity plus equals 100, return mass times gravity, print get force 60, would output unbound local error, local variable gravity reference before assignment. Probably shouldn't be manipulating gravity anyway. Let's practice accessing values in the global scope to get a hang of it. Take a look at the two functions defined. One function named print available prints the number of gallons we have available for a specific color. So print available takes in a color, prints the gallons available, print there are string paint gallons available of the color plus gallons available of this paint. Oh, okay, there are this many gallons available of that color of paint. Got you. Take a look at the two functions provided, and then this function print all colors available for color and paint gallons available. So it's not going to be able to access that. Print color, print available red. Oh no, I don't need that. Leave me alone. Take a look at the two functions defined. One function named print available prints the number of gallons we have available for a specific color. The other function named print all colors available simply prints all available colors. Ponder what might happen when we run the script and run it to find out. Name print gallons available is not defined. Whoops, looks like we have an error with accessing paint gallons available in our print all colors available function. This is because the dictionary is locally scoped. Fix the issue by moving paint gallons available into the global scope. So copy that. Put it up there. Should be good now. Cool. Modifying scope behavior global statement. Sometimes we want to modify a global name from within a local scope. How do we go about doing this? Global var equals 10, def sum function, global var equals 20, sum function, print global var. So global var equals 10, def sum function tries to redefine global var as 20. We run sum function and we print global var, but it doesn't manage to redefine it. In the above example, the value of global var remains 10 because global var equals 20 is in local scope. Similar to the non-local statement, Python provides the global statement to allow the modification of global names from a local scope. So here we do global var equals 10, def sum function, global var equals 20, sum function, print global var. The output would now be 20. In addition, the global statement can be used even if the name has not been defined in the global namespace. Using the global statement would create a new variable in the global namespace. So if we do def sum function global x equals 30, sum function print x, this would output 30. In summary, the global keyword is used within a local namespace. In summary, the global keyword is used within a local scope to associate a variable name with a name in the global namespace. This association is only valid within the local scope when global is used. This exercise starts the same as the difference now is that paint gallons available is now being accessed by a for loop in the global scope. This will result in an error. Run the code to confirm the name error on paint gallons available. Name error, paint gallons available not defined. Associate the paint gallons available declaration to the global namespace by adding a line to the top of the print available function. This will, so global paint gallons available. This will allow paint gallons available to be used within the global scope and no name error will occur. Scope resolution, the LEGB rule. While most of our focus so far has been around where we can access namespaces, To truly get a full picture of scoping rules, we must also examine how Python handles scope resolution. Scope resolution is a term used to describe a search procedure for a name in the various namespaces. A set of rules dictates the order that the search needs to follow. In Python, the unofficial rule, often referred to in literature but does not exist in the official documentation, is known as the LEGB rule or the LEGB rule. LEGB stands for local, enclosing, global, and built-in. These four letters often represent the order of namespaces. Python will check to see if a name exists. Here's a visualization of the order: the local, the enclosing, the global, the built-in. To see this rule in action, let's take a look at two specific scenarios where Python is searching for a name. The first scenario is a nested function that wants to print a variable called age. Age equals 27. Def func, def inner func, print age, inner func, would output 27. So this inner function is trying to print age, which is in the global scope, so that's fine. We run our inner func in the function, and when we run the function, it's gonna print the age. So what exactly happened here in terms of scope resolution? It went a bit like this. First, Python looked in the local, the L of LEGB scope that existed inside of inner func. This is the lowest level of the LEGB rule, and thus where Python starts the search for a name that is trying to be called, in this case via a print. Python then realized that the name of age isn't in the local namespace and continues to search to the upper levels of scope. The second level of Python examined in the enclosing scope the E of LEGB of func. Unfortunately, again, the name of age doesn't exist in the enclosing namespace, and Python moves upwards to higher scopes. Next, Python arrives at the global scope and finds the name of age in the global namespace. The search is finished and the result is returned. This process of scope resolution is crucial to understanding how programs are able to access names in different scopes. Keep in mind the order that Python searches always start at the lowest level, the local level, and always flows upward to the higher scopes. The second scenario to examine is seeing what happens when we have two of the same names in different namespaces, or two of the same name, whatever. Let's examine the same script, but with a slight modification that creates a second name called age in a different namespace. Here's what it looks like. Age equals 27, def func, age equals 42, def inner func, print age, inner func. Here the output will be 42 because Python could find a name age in the enclosing scope and did not continue to search for the value up into the global scope. If Python cannot find a name in any of the four scopes it searches, it will return a name error exception. Using the LEGB rule, we are going to try and correct this function to behave how we expect it to. It should replace the color with a new provided color and print out the old and new colors. Try running the code to see what the first issue is. So color equals green, def change color new color, global color, color to update. So first of all, color equals to update. That's, you're trying to assign a variable to update to color. And I see now. Def display color, print the original color was plus color to update equals new color. So you're trying to assign this in here, which I guess would work, except you're trying to do it before it even reaches here. So by the time you run display color, you've already run into this error where to update is not defined. Print the new color is color, change color blue. So name to update is not defined. The LEGB rule starts with local. Let's take a look at any local variable issues that we could be running into. Looking at each of the local variables, we can see that to update is local to the function disp color, but we attempt to access it from change color. Move the initialization of to update so that the scope is local to change color. Try running the code now and see what happens. So move the initialization of to update so that the scope is local to change color, okay? And it works. Now we are not getting any errors. Oh wait, but the output is not correct. There doesn't seem to be any encompassing scope issues, but there is an issue with the global variable color. It's an issue here. We're using the global keyword to allow color to be modified in order to print the new color. if we look at the order of operations, we modify the global variable before calling. Modify this before calling display color. To fix this, move the change to the variable color to after display color. Oh, it's tweaking out, huh? The after display color is called before the new color is output. Run the code. Nice, working right. Review, great job. You've learned some important concepts in Python regarding scope. In this lesson, we've covered the concept of scope and the Legby rule, what the local scope is, what a nested function is, and the enclosing / non-local scope, what the global scope is, how to modify behavior using the global statement, how to modify behavior using the non-local statement. Knowing these concepts allows for a stronger mastery of Python when working with names and programs and taking into consideration what parts of the programs that can be accessed or modified. Keep up the great work. The code in the workspace declares function 1, which has a nested function, function 2. Within each function, body variables are declared, and the global and non-local keywords are used. Inside the function 2 body, the globals and locals namespaces are printed. Before you run the code, can you guess which namespace each variable will be in? So, def function global var1. So this is in the global namespace. var2 will be in enclosing. So non-local var2. I actually kind of forget, what does non-local do again? Non-local, I forget the difference between non-local. I guess non-local will allow it to be enclosing, so I guess enclosing. Closing global var3. So I guess move these down here. So var3 is global. And when we print the globals, so var2 is the locals, well yeah, enclosing local, whatever, and var1 and var3 are in the global. Cool. How am I doing on time? That's pretty much my time. Oh, let me do this first. Fill in the code so that the script will output 190. Def use gift card purchase amount. So we end up sending it to 10. Gift card balance equals 200. Def subtract. So you do global or non-local. You could do non-local. Gift card balance. And then do gift card balance minus equals purchase amount. And then we run subtract. And then we print gift card balance in this use gift card function. That should work. What is the expected output of the following code? Def get color position. Color list equals these colors. RoyGBiv print color list position. Color list 2, so we send it 2. And we want to print this yellow. The code will run, in this case return yellow. Is there any error here? Oh wait. We're trying to run color list. What is even happening here? This is crazy. Well, we're not trying to run a function actually. We're trying to just, I don't know what we're trying to do, but this is not going to work. What is the expected output of the following code? So color list is not defined in here. So I think it would be a name error. Fill in the blanks. In the code below, the print replicated greeting function is able to access the name replicated even though it was defined in a different function. This is because print replicated greeting is a nested function, and as a result, replicated is in its enclosing or non-local scope. Nested enclosing. All executed functions have access to the surrounding local enclosing, global, and built-in scopes. All executed functions have access to the surrounding. That's worded weird. What does surrounding mean, you know? If you said encompassing, then I would say true. But surrounding, I mean, if I assume that surrounding means encompassing, then you could say that all executed functions have access to the encompassing local, enclosing, global, and built-in scopes. It's just a weirdly worded sentence. Has access to the surrounding scopes. Surrounding, I guess that's true. Only nested functions. See, it was worded weird. That's not what I mean. If we ran the following block of code, what would the output be? My var equals global, def print var, my var equals enclosing, def nested print var, print my var, nested print var. So we have my var equals global. This def nested print var is going to try to print my var, so it'll print enclosing. We run it, and then we run this. So when we run this, it sets my var to enclosing, and it runs this, which prints, so it'll print enclosing. Fill in the code so that the script will output. We ran this function 1 times, ran this function 2 times, ran this function 3 times, x equals 0, def counting function. So if it's global x plus equals 1, print, we ran this function x times, counting function 0, global x, right? Ran this function x, so the first time you run it, it makes x global, so that this will add it to this. Second time you run it, I'm pretty sure that's right. Yeah. In Python, scope defines which namespaces a program will search within and in what order. It's true. Continue learning. We'd love to hear about your experience. Pretty satisfied. I want to exit the survey. Survey isn't satisfying me. Lambda functions. This is an exciting topic, so I'm going to read this. Learn how to define a Python function in 1 line. In Python, a lambda function, also commonly called an anonymous function, is a 1-line shorthand for function. Let's start by examining how lambda functions compare to the normal functions we have already been writing. Take, for example, a function called add2. Def add2, my input, return my input plus 2. So here we have a function called add2, takes in an input and adds 2 to it and returns it. The same function can be written as a lambda function. Add2 equals lambda, my input plus 2. So the name of the function, so add2 is a function which takes in my input, and what does it do to it? It does my input plus 2. Or you should say, I guess, it returns. So lambda takes in my input and returns my input plus 2. So again, in Python, a lambda function, also commonly called an anonymous function, is a 1-line shorthand for a function. Let's start by examining how lambda functions compare to the normal functions we've already been writing. Take, for example, a function called add2. So this code, using the above lambda function, if we do print add2 3, print add2 100, print add2 -2 would output 5, 102, and 0. Let's break this syntax down. The function is stored in a variable called add2. The lambda keyword declares that this is a lambda function, similar to how we use def to declare a normal function. My input is a parameter used to hold the value passed to add2. In the lambda function version, we are returning my input plus 2 without the use of a return keyword. The normal Python function explicitly uses the keyword return. So in the lambda function version, we are returning my input plus 2 without the use of a return keyword. Normal function, Python function explicitly uses the keyword return. Let's practice identifying a conversion from a normal function to a lambda function. Multiple choice. Which of the following is a proper conversion of the function below into a lambda function? So def add bang takes in a sentence, prints the sentence plus an exclamation mark. So add bang equals lambda string. So it takes in a string and prints string plus exclamation mark. So it'll be this. Good job, you got it right. Our lambda functions can be more complex than the above example. For instance, let's say we want a function that will perform differently based on different inputs. Let's say that we have a function check if a grade that outputs got an A if a grade is at least 90 and otherwise says you did not get an A. So the code print check if A grade 91, print check if A grade 70, print check if A grade 20 would output got an A, did not get an A, did not get an A. We can do this using a conditional if statement in a lambda function with syntax that looks like this. Check if A grade equals lambda, takes in grade, got an A, if grade is greater than or equal to 90, else did not get an A. This is what our line of code does. Lambda grade declares a lambda function with the parameter grade, return got an A if this statement is true, return got an A if this statement is true, otherwise return did not get an A. Lambda functions are the preferred way of creating one-line functions. The reduced syntax assists code readability, and the functions can be implemented where code reuse is not the primary objective. If we wanted our function complexity to extend beyond one line, we would opt for a regular function, since making our function longer would impair readability. Now, we can make simple Python functions in one line. Let's get some practice in. Fill in the blanks to complete a lambda function named $0 or 0 that takes an integer named num. So $0 equals lambda num. If num is greater than 10, return double the value of num. So lambda num times 2. If num is greater than 10, num greater than 10, otherwise return 0. Got it. What's next? Introduction to higher order functions. Okay. I still got a little bit of time. Okay, since the next two sections have to do with higher order functions, I'm going to save this for next time. And but I feel good about progress I've made. Got through function arguments and got through namespaces and scope and learned about lambda functions. So we're about halfway through, not halfway actually, maybe two sections, let's call it 2 sections. So 2 and some change. So we're about a third of the way through. So I'm feeling good about the progress and where are we at with this? Cool.